Hello and welcome to Morehouse School of Medicine demonstration of i2b2. My name is Matvey Palchuk. I will show basic functionality of i2b2 web client. Let me start by logging into the system. I'm going to use the Morehouse School of Medicine username and password. The system is integrated with the Active Directory at the school. Once the system loads, you see the basic features of the interface. i2b2 is an ad hoc query builder for querying patient data that was accumulated at the point of care. At the Morehouse School of Medicine, the system is loaded with data from the EMR that is in use at the School of Medicine. Specifically, the data that's available for querying contains demographics information, diagnoses, problems, procedures, selected laboratory tests, and medications. For the purposes of today's demo, I'm going to create a cohort of patients who have diabetes. We're going to start with the problem list, and we're drilling down into the ICD-9 hierarchy of diagnosis, looking for diagnosis of diabetes. I will expand endocrine and find diabetes mellitus. Let me expand the panel and show you that under diabetes mellitus itself, the hierarchy continues to very specific individual diagnosis and problem list entries identified by ICD-9. Because this is a tree in the hierarchy, the user can drag concepts from any level of this tree into the query builder, and if one does so with a concept that is higher up in the tree than the terminal nodes, all of the children of that specific concept are going to be included in the query. So we've just dragged in diabetes mellitus. What you see here on the right side of the screen are several panels that are logically joined to each other with an AND. And essentially, this is a graphical query builder. And the type of query that i2b2 allows you to construct is going to answer a question: how many patients are there that satisfy the criteria that are basically represented in this panel? So if we run a query as is, it is basically asking a question: how many patients have an entry of diabetes mellitus on their problem list? So let us run this query. And you can see at the bottom of the screen in the query status panel, it just finished in a very short time and gave us an answer. There are about 630 patients that satisfy this criteria. Let us assume that in using this specific EMR, not everybody documents diabetes on the problem list. And so we're going to go into labs and see if we can expand our definition of diabetes and grab more patients by including hemoglobin A1C into our query. So I'm going to grab hemoglobin A1C, drag it into my panel. When I drag more than one concept into a single group, they're logically ORed together. So here I'm going to be asking a question: how many people have diabetes mellitus? And the result of hemoglobin A1C, and here I'm definitely going to restrict this concept, the hemoglobin A1C, and ask specifically how many people will have hemoglobin A1C greater than 7%, for example. So let us run this query. And now we expect the number to get a little bit higher, and indeed it does. Let's also consider that perhaps some folks are getting their labs done at a third-party lab, and perhaps the system doesn't have their records. So why don't we add to our definition those who are being treated for diabetes? So we're going to go and look for glucose regulation agents, and we're going to drag in insulins and oral hypoglycemic agents all into this definition of diabetes. And let's rerun the query again. This time we're hoping for a larger number of folks. So here we have 3,400 patients satisfying this specific criteria. So now we have a cohort of patients who satisfy our criteria of diabetes. Let's assume that I am interested in patients that live in a certain geographical area. So I'm going to go onto demographics into zip codes. We'll drill in Georgia, Atlanta, and I'm going to pick up a specific zip code in the west side of the city, and we'll rerun the query. As you can see, I dragged it into a separate panel, and so now I'm asking a question: how many people satisfy these diabetes criteria and reside in the area that's served by the zip code 30318? So here I would expect my patient count number to be lower than before because we're now looking at a subset of patients, and that is indeed the case. We ended up with 198 folks. At this point, we have a cohort of patients that we're interested in, and I would like to show some of the capabilities of this client in terms of visualizing data. So before I do that, I will rerun the query and ask the system to save this patient set. What this does is, in addition to saving a number, it also saves synthetic identifiers for these patients who are loaded to the system and satisfy this query. And let me rename this query so it's easy to find in our history. I'm going to call it diabetes in 30318. We will run it. And as you will see in the left side bottom panel of the screen, previous queries, here is our query that was just run. And if I expand it, you will see the set of patients, these 198 folks, were saved. I'm going to go to the upper right side of the screen, switch the view to analysis tools, and pick up one of the plugins that ships with i2b2 that's designed to visualize a cohort of patients in terms of their demographics. I'm going to take my set from the previous query that I ran, drop it here, and ask to view the results. What you will see is a histogram generated that will show breakdown of patients in this cohort by various demographics parameters such as age and gender. Let us go further with the demo and consider a couple of other scenarios. Let's imagine that I am interested in conducting a study where I will look at people who have hypertension in addition to their diagnosis of diabetes. So I'm going to return to my ontology, and on the problem list, I will find I will find hypertension, diseases of the circulatory system, hypertensive disease, and I'm going to drag it into my query, again adding it as an AND to other parameters here. Let us run this query. Before we do so, I will rename it, and I will say that these are people who have diabetes with hypertension. I will again ask the system to save my set. Say OK. And so let's imagine that this would be our intervention cohort for this imagined study. And I would also be interested in constructing a control cohort. And so let's grab the folks who do not have hypertension from the same group. I can do so by clicking exclude button, and this essentially changes the logical operator that joins this concept to the rest of the concepts in my query from AND to AND not. And so if I run this query now, it will ask for people who have diabetes who reside in 30318 zip code area and do not have hypertension. Let's do so. Once again, we will rename the query with something friendly so we can easily identify it. So these are diabetics without hypertension. We run the query, and we have our number. Let's switch our view again to analysis, and this time we will pick up a different plugin. This one is called Demographics two patient sets, and this one allows us to compare two cohorts. So I'm going to drag and drop the patient set that represents my diabetics with hypertension, and into the other field, the patient set that represents my diabetics without it. And this time, the histograms are going to be generated comparing two cohorts. So this is an example where a researcher can do a lot of preparation for their given study in terms of learning how many patients satisfy certain criteria and going even as far as beginning to construct specific cohorts of patients. The last plugin that I wanted to demonstrate in visualizing data is something that's called a timeline. To demonstrate this one, I'm going to go back to our set that contained all the diabetics. I will drag it into the plugin, and let us say that I'm interested in finding out how well these people are being followed in terms of checking their cholesterol levels. So we're going to go into labs, expand chemistry, and we'll just grab lipids as a concept that we're interested in visualizing in terms of timelines, and then ask the system to view results. Let me increase the number of patients that are being shown on a given page to 100. And so what we see here, there's a row for every patient in our patient set, and there's a timeline that is synchronized across all the patients, and there are hash marks that correspond to a fact, in this case, a test from one of the tests that resides under the lipids folder in our chemistry hierarchy of lab results. And so here we can see that the first patient on our list, a 53-year-old male, is being regularly checked for his lipids lately, and this 90-year-old female has been getting regular checks and somewhere in the early 2000s and has not been since. So here's a way to visualize certain facts about a patient in terms of their temporal distribution. More than one concept can be dropped into this plugin, and so this can be used to look at various causative effects between, for example, diagnosis, therapies, and so on. This concludes the demonstration of i2b2. Thank you very much for your attention. That's it.